Everything you've been told about ancient homes being cold, smoky, and uncomfortable is mostly wrong. Germanic longhouses kept entire families warm through brutal winters without chimneys, insulation, or modern heating, and they did it reliably for centuries. The real story isn't survival, it's smart design, practical knowledge, and a way of building that worked with nature instead of fighting it. Once you understand how a longhouse worked, it stops looking primitive and starts looking surprisingly efficient. How did Germanic longhouses stay warm through harsh winters without chimneys, insulation, or sealed windows? And why did a design that looks simple at first glance work so reliably for centuries? Stay with Germanic Under Constraint as we explore how structure, materials, fire placement, and daily habits turned these wooden halls into naturally heated spaces long before modern heating existed. Understanding the Germanic longhouse. Germanic longhouses were not temporary shelters. They were carefully built homes designed to last for decades and support entire households that included families, workers, and sometimes animals. These structures appeared across Northern Europe from the Iron Age through the early medieval period, with regional variations but shared core principles. Most longhouses were long rectangular buildings made primarily from timber frames with walls of wattle and daub or planks. Roofs were usually thatched with straw, reeds, or turf. Their size allowed multiple activities to happen under one roof: cooking, crafting, storage, sleeping, and social gatherings. Because winters in Northern Europe were cold and damp, staying warm was not optional. It was a necessity for survival. The longhouse was designed from the beginning to hold heat efficiently using simple physical principles rather than mechanical systems. The central hearth, the heart of warmth. At the center of most longhouses was an open hearth. This fire burned continuously for cooking, light, and warmth. Instead of being placed against a wall like later fireplaces, the hearth was usually located along the central axis of the building. This placement allowed heat to spread evenly in all directions. Warm air rose toward the roof and gradually circulated through the interior. Because the fire was central, no part of the house was too far from the heat source. The hearth was not excessively large. A steady, controlled fire produced consistent warmth without overheating the space. Over time, households learned how to maintain fires that burned efficiently with minimal fuel, while still providing enough heat for daily life. Why there were no chimneys. One of the most surprising features of Germanic longhouses is the absence of chimneys. Instead of directing smoke through a vertical shaft, smoke was allowed to rise and slowly escape through small openings in the roof or through the thatch itself. This might sound uncomfortable, but it served several purposes. First, smoke moved slowly, which meant more heat remained inside instead of escaping quickly. Second, smoke helped preserve wooden beams and thatch by discouraging insects and reducing moisture buildup. The upper part of the longhouse often held a layer of warm, smoky air, while the lower living area remained breathable. Over generations, people adapted to this environment, and ventilation openings were adjusted depending on weather conditions. The role of thatch and roofing. Thatched roofs were not just convenient, they were excellent natural insulators. Thick layers of straw or reeds trapped air pockets that slowed heat loss. The steep slope of many roofs also helped shed rain and snow, keeping the structure dry. Dry materials hold heat better than damp ones. Maintaining the roof was therefore essential. Regular repairs ensured the thatch stayed thick and functional. In colder regions, turf roofing added additional insulation through layers of soil and vegetation. Because warm air rises, the roof played a major role in keeping heat inside. A well-maintained roof could dramatically improve comfort during winter months without requiring additional fuel. Thick walls and thermal mass longhouse walls were often built using wattle and daub, a mixture of woven branches covered with clay, mud, straw, and sometimes animal dung. Once dried, this created solid walls with good thermal properties. These materials absorbed heat during the day and released it slowly as temperatures dropped. This process, known as thermal mass, helped stabilize indoor temperatures. Even after the fire burned low, the walls continued releasing stored warmth. Timber planks used in some regions also helped reduce drafts, especially when combined with earth-packed floors that minimized cold air movement near ground level. Small openings and controlled airflow. Longhouses had very few openings compared to modern homes. Doors were narrow, and windows were either small or absent. This limited heat loss and prevented strong winds from cooling the interior. Ventilation was controlled rather than constant. Smoke openings and doors could be adjusted to regulate airflow. This allowed fresh air to enter slowly without rapidly losing warmth. By minimizing uncontrolled drafts, the longhouse maintained a stable internal climate even during severe weather. Shared space and body heat. Longhouses were communal spaces where many people lived closely together. This naturally contributed to warmth. Human body heat, combined with the presence of animals in some longhouses, helped raise the indoor temperature slightly. Sleeping areas were often positioned along walls or raised platforms where warm air collected. Bedding made from wool, furs and straw provided additional insulation during the coldest months. This shared living arrangement made the longhouse feel warmer than its size might suggest. Animals as natural heat sources. In many Germanic longhouses, livestock such as cattle or sheep were kept in a section of the building during winter. This practice was practical for protection and feeding, but it also contributed to heating. Animals produced body heat continuously. Keeping them under the same roof added a steady source of warmth that reduced the amount of fuel needed for the hearth. While the spaces were usually separated to maintain cleanliness, the shared structure allowed heat to circulate throughout the building. Fire management skills. Maintaining a hearth required knowledge and experience. Fires were not left to burn randomly. Fuel was added carefully to control temperature and smoke levels. Wood selection mattered. Hardwoods burned longer and produced steady heat, while softer woods helped start fires quickly. Ashes were often left to insulate embers overnight, making it easier to restart the fire in the morning. These daily habits ensured the longhouse stayed warm without wasting resources. Seasonal adaptation. Longhouses were used differently depending on the season. During winter, activity centered around the hearth and openings were kept minimal. In warmer months, doors and vents could remain open for airflow. This seasonal flexibility allowed the same structure to remain comfortable year-round without major changes. People adjusted their routines rather than relying on structural modifications. Understanding seasonal patterns was key to maintaining a stable living environment. Smoke as protection and preservation. While modern homes aim to remove smoke entirely, small amounts of smoke in longhouses provided benefits. Smoke helped preserve food hung from rafters, keeping meat and fish from spoiling quickly. It also protected the structure by reducing insects that could damage wood or thatch. Over time, smoke-darkened beams became more resistant to decay. This meant the heating system also contributed to maintenance and food storage. Comparison with later chimney houses. When chimneys became more common in later medieval Europe, they improved indoor air quality, but often reduced heating efficiency. Heat escaped more quickly through chimney shafts, requiring more fuel. Longhouses prioritized heat retention over smoke removal. While not as comfortable by modern standards, they were efficient within the limits of available materials and technology. This shows that longhouse design was not primitive, it was optimized for its environment. Why the system worked so well? The success of the Germanic longhouse came from combining multiple simple strategies rather than relying on a single solution. Central fire placement, insulating materials, controlled airflow, and shared living all worked together. Each element supported the others. Remove one and the system would be less effective. Together, they created a balanced environment that remained functional through long winters. The design reflected practical knowledge passed down through generations rather than formal engineering. What longhouses teach about practical design. Germanic longhouses demonstrate that effective heating does not always require complex technology. Understanding materials, airflow, and human habits can create comfortable living spaces even in challenging climates. These homes were built with available resources and maintained through daily care. Their longevity shows that simple solutions can be highly effective when they match environmental conditions. The longhouse is a reminder that good design often comes from observation and experience rather than innovation, often dashing Germanic. Modern heating relies on energy, not structure. Modern houses stay warm mainly through external energy systems rather than passive design. This approach allows precise temperature control but depends heavily on fuel or electricity supply. In contrast, Germanic longhouses relied primarily on structural efficiency rather than mechanical output. Modern buildings are often designed with thinner walls and larger openings because heating systems compensate for heat loss. Insulation materials like fiberglass, foam boards, and double-glazed windows prevent rapid temperature change, but they require industrial production and maintenance. The difference highlights how modern comfort depends on continuous energy input, while longhouses depended more on physical layout and material behavior. Both approaches are effective, but they reflect different technological contexts and resource availability. Germanic longhouses stayed warm not because of a single invention, but because every part of the building worked together with daily life. What looks simple today was actually a practical response to climate, materials, and survival needs. These homes show that warmth does not always come from advanced technology. Sometimes it comes from understanding how to work with the environment instead of against it. The longhouse was not just shelter, it was a carefully balanced living system that kept people safe through some of the harshest winters in Northern Europe. The story of the Germanic longhouse reminds us that good design often begins with observation, not invention. What surprised you most about how these homes? Share your thoughts and stay with us as we continue exploring how ancient Germanic societies solved everyday problems with knowledge, skill, and experience long before modern technology existed.